Other people are still joining in. So anything you want to ask or share till other people join?
सर जो हम लोग अभी तक किए एक बार बस उसको रिवाइज करते हुए अभी नेक्स्ट हम लोग करेंगे सर।
ओके बेटा, I'll quickly give a recap to you. सबसे पहले हमने देखा था basic properties of magnetism, and then we went into the Earth's magnetism. The most important thing in Earth's magnetism is the direction of the magnetic field lines. So we saw they always go from south to north, but their vertical orientation changes. In the southern hemisphere, they come up, and in the northern hemisphere, they go down. So that was the first thing what we saw. Then we saw the ship's magnetism. Ship's magnetism is of two types. You could have permanent magnetism in hard iron structures, which are worked upon by way of hammering, bending, welding, cutting, high temperature, high voltage currents. So they will acquire permanent magnetism. This permanent magnetism will depend upon what was the heading of the ship and what was the latitude where the ship was built. And the second part of ship's magnetism is induced magnetism. Induced magnetism is generated in soft iron structures. These are fore and aft longitudinals, athwart ship beams, vertical stiffeners, masts, derrick, crane, funnel. So all these structures. And this induced magnetism is temporary in nature, and it keeps on changing as the ship changes its heading as well as position. The poles keep on changing. Then we went into the coefficients. The first coefficient, coefficient alpha, was caused because of unsymmetrical pair of HSI, horizontal soft iron, which is usually absent on a normal merchant vessel. We saw that coefficient alpha remains constant over all 360 degrees of headings. Then we went into coefficient Bravo. Bravo was proportional to sine of the compass course. So sine 0 and sine 180 both are nil. So this deviation is nil on north and south headings. And sine 90, sine 270 has maximum value. So Bravo is also the most powerful on east and west headings. Then we came to Charlie. Bravo has two parts, permanent B and induced B. So then we went to Charlie. Charlie is proportional to cos of the compass course. That means maximum on north and south headings and minimum on east and west headings. So this also has two parts, permanent and induced. The permanent C is caused because of permanent magnetism in outward ship direction. Induced C is caused because of a vertical structure, port or starboard of the compass. So this is what we covered till now. And now we are moving to a combined correction of IB and IC.
Copy it, sir. Thank you, sir. So basically, IB is for only funnel and IC is for any structure other than funnel.
No, IB is for any structure forward or aft of the compass. And IC is for a vertical structure port and starboard of the compass.
Understood, sir. Same like IB is for forward aft. Like PB was forward aft of permanent magnetism, and IB is for forward aft induced magnetism. Same IC is for athwart magnetism, and IC is for induced in athwart direction.
Right, beta.
So,
Okay, great. So most of the people have joined in. So let's go into the presentation and see. Go ahead, Prabhat.
Yes, I just want to ask, like, when we are going to start this numerical of this charo, like, what?
Beta, after magnetism, the next topic is gyro.
So the gyro numericals and theory both we will cover.
First, we'll cover the theory part, then we will cover the numericals.
Okay, sir. Thank you.
Okay. So let's go into the presentation, beta. So this was the last coefficient which we saw yesterday, induced C deviation. And now we are going to see if IB and IC both are present together on a shape, how they are corrected by using a single Flender bar. We saw IB and IC can be corrected using different Flender bars, but if they are present both together, they can be corrected using a single Flender bar also. So that's what we are going to see. So moving ahead now. Now, one important thing to understand here is that if a merchant vessel has both the coefficient IB as well as IC together, we have a method with which both these coefficients can be corrected in one go. Instead of using two Flender bars, the correction can be done using only a single Flender bar, which will correct both these coefficients together, induced P as well as induced C. So how is this done? Let's see. A merchant vessel will definitely have induced B because of the funnel, the mast, vertical structure, fore and aft of the compass will certainly be present, and it is corrected using a Flender bar forward or aft of the compass as required. If induced C is also present, then another Flender bar will be required to port or starboard of the compass opposite to the VSI. It is very much convenient to use only a single Flender bar and slew it. Slew basically means turning it from the fore and aft line to port or starboard of the compass. So the fundamental of this correction is that we take a single Flender bar, instead of placing it forward of the compass, we slew it or we turn it in a direction which is opposite to the resultant of IB as well as IC. So once it is placed in that way, this is able to correct this Flender bar, single Flender bar is able to correct both these coefficients together. I will explain this to you in detail using a diagram. So let's move ahead. Now, the first question which arises in our mind is, how do we determine the angle by which the Flender bar should be slewed? This is also called as the slew angle. And also, we need to know what is the direction in which the Flender bar should be slewed, to clockwise or to anti-clockwise. These are the two things which we need to know before we correct a IB and IC combination using a single Flender bar. Now for this, let us understand it using one example. Let's assume that in the diagram, you can see the laser pointer. In the diagram, this is the compass location where the laser pointer is right now. Now we have a funnel which is aft of the compass needle. The ship is right now, let's assume the ship is heading north 000. So we have the Flender bar at this particular location. So this Flender bar is generating IB or induced P component. So this vector represents the IB component. Now let's also assume that on this particular ship, there is a vertical soft iron structure to starboard of the compass, and that structure is present here at this particular location. Now this structure is going to cause induced C, and this vector where the laser pointer is right now, this vector represents the component or coefficient IC. Now, if we take a resultant of these two coefficients, the resultant can be easily obtained by making a parallelogram. So if you make a parallelogram using these two IB and IC vectors, the diagonal of the parallelogram, this diagonal of the parallelogram gives us the resultant of these two forces. Now we can find out the magnitude of this resultant by using the Pythagoras theorem. It will be equal to the base square plus the perpendicular square under root. That is IC square plus IB square under root will give us the magnitude of this effect, which is the resultant effect of IB and IC. Also, we can easily find out this angle. This is the angle between the 4.5 line. This is the 4.5 line and the resultant of IB and IC. In the diagram, we have represented it by capital M, and this particular angle, capital M, basically gives us our slew angle. We can easily find out this angle M. Now, we know tangent theta is equal to perpendicular upon base. So tangent of this angle M will be equal to the perpendicular. You can see the perpendicular is basically the IC component, and the base is the IB component. So you see tangent of this angle will be equal to IC upon IB. So you can see the formula here. Tangent of the slew angle is equal to IC upon IB. So if we know the magnitude of IB and we know the magnitude of IC, then we can easily calculate the slew angle. The slew angle, once calculated, gives us the information how much turning or slew is required for the flunder bar. Now the flunder bar has to be placed in a direction which is opposite to the resultant of these two forces. So opposite to the resultant, we place the flunder bar somewhere here in this direction. The magnitude of the flunder bar or the length of the flunder bar is decided by the magnitude of the resultant, and the slew angle is this angle M, which we have calculated using the formula tan of slew angle is equal to IC upon IB. Now, when we make the combined correction for IC and IB, we have to also find out what is the heading on which the ship should be when the correction is made. Now, coefficients are always corrected on a heading on which they produce maximum deviation. For the resultant of IC and IB to cause maximum deviation, it should act perpendicular to the needle. The compass needle always lies in the north-south direction. So for the force to act perpendicular to this direction, this resultant vector should be acting in the easterly direction. If this resultant vector is in the easterly direction, it will be acting at right angles to the compass needle, generating maximum deviation. Now for this resultant to lie in the easterly direction, it has to swing by an angle, or the vessel has to swing by an angle equal to 90 minus m. You can see the laser pointer. This is the angle by which the vessel has to be swung to the port side so that the resultant is acting in the easterly direction, which is perpendicular to the compass needle heading north and south, or aligned in the north and south direction, generating maximum deviation. So swing the ship 90 minus m degrees to port for the combined correction. Now another option which is available to us is if this resultant vector acts in the westerly direction. If it acts in the westerly direction, even then it will be acting at right angles to the compass needle, and this will happen when the ship is on a reciprocal heading to the initial one. If you swing the ship 90 minus m to port, we obtain one of the headings, and also on a heading reciprocal to that, 180 degrees apart from that, you will see that this is the second option available to us to correct IB and IC together. Go ahead with your doubts, beta.
सर ये लास्ट वाला पॉइंट एक बार एक्सप्लेन कर देंगे जो 90 माइनस एम किया गया ईस्टर्ली हेडिंग पे, वो वाला पॉइंट कैसे समझ में?
Okay, beta, I'll explain it once again. For this resultant of IB and IC to generate maximum deviation, it should act at right angles to the needle or right angles to the magnetic field lines. So it will act at right angle if it is in the easterly direction or westerly direction. So how can we bring this resultant east of the compass? So for that, the vessel needs to swing to the port side by this yellow color angle. This angle is 90 minus m. If you swing this much angle to the port side, the resultant will be in the easterly direction, generating maximum deviation. So that is where the correction is made. Getting clear, beta?
सर थैंक यू सर.
सर इन द डायग्राम वेयर जहाँ पे आपने स्टार बनाया है, दिस इज वेयर structure over there.
No, beta. The structure is on the right side where IC is written. You see, it is mentioned here,
structure
vertical structure causing IC. You can forget the star for the time being.
this sir, but how much will be the magnitude of IC and IB? ये हमें कहाँ से पता चलता है?
Okay, now this will be an estimate made by the compass adjuster. He will see the size of the funnel. He will see what is its distance from the compass. And using the size as well as the distance, he will make an estimate. So this is by estimation. For a normal merchant vessel, a normal size funnel, this IB correction is about 3 degrees or so. 3 degrees of correction is there for a normal merchant vessel. If the funnel is big in size or it is close to the compass, then it is suitably increased. And if it is too small or far away, then this 3-degree value is reduced. Okay, beta. Great. Let's move ahead.
Excuse me, sir.
Bolo, beta.
Yes, sir. So it means that we have to swing the ship 90 minus m, and then we will place the cylinder pass in that direction.
That's correct, beta. That is correct.
After it is on the heading 90 minus m, then it will be
Right.
placed m from the small m from the heading.
That is correct. That's correct. अब बेटा इस पे कई बार हमारे पेपर में ना प्रैक्टिकल क्वेश्चन भी आता है, तो मैं अब आपको एक एग्जांपल दिखाने वाला हूं विच इज बेस्ड ऑन दिस पर्टिकुलर प्रिंसिपल. सो लेट्स गो देयर. आई विल स्टॉप दिस प्रेजेंटेशन. आई विल पुट ऑन ए न्यू वन. Just give me 1 minute, beta. Just hold on. Okay, can you see the presentation now, beta?
Yes, sir.
Okay, all right. So let's see this question. It is based on this particular principle which we have just now seen. Let's see it. We move on to the next question. The question says, on board your vessel, you have noticed that the Flinders bar is attached to the binnacle in a relative slewed direction. That is 015 degrees instead of usual direction of ship's head. Part A of the question asks, analyze and discuss the reason for such an arrangement. And part B asks, what would have been the ship's heading on which the maximum deviation occurred prior to the Flinders bar correction? So let us first try to understand the meaning of the question. Let's make a diagram of a ship. You can see a particular ship here. We have shown the binnacle. We have shown the fore and aft line. You can see this dotted line here, the fore and aft line. And we have also shown the authwardship line here to have a sense of directions. Now the question says the Flinders bar is attached to the binnacle in a relative slewed direction of 015 degrees. Now the 015 degrees is basically the relative direction of the Flinders bar with respect to the ship's head. So from the ship's head, if you go 15 degrees, let me show you here in the diagram. You can see from the ship's head, if we go 15 degrees, the relative bearings are measured clockwise from the ship's head. So if you go to this 15 degrees direction, this is where the Flinders bar lies. You can see this yellow color Flinders bar shown in the diagram now. So first part of the question says, analyze and discuss the reason for such an arrangement. Now on a usual ship, the Flinders bar opposes the vertical soft iron present on the ship. On a normal merchant vessel, the main vertical soft iron, most predominant vertical soft iron which we have is the funnel. The funnel is usually exactly aft of the compass. So to compensate the funnel's effect, the Flinders bar is fixed up just forward of the compass. But in this case, the Flinders bar is slewed 15 degrees. Now that means that the magnetic field generated because of vertical soft iron is not aft of the compass. The magnetic field which is generated must be opposite to the direction where the Flinders bar is. So that means that whatever magnetic field is there on the ship because of vertical soft iron will have a resultant direction opposite to where the Flinders bar is. So as you can see, this red color arrow shows us the direction of the resultant magnetic field caused because of vertical soft iron. So if the vertical soft iron causes a field in this direction, in the direction of the red arrow, the Flinders bar is fitted. The yellow color round represents the Flinders bar, will cancel its effect and the compass will be corrected. Now, how can we have the resultant in this particular direction? Now we are aware that exactly aft of the binnacle, we will have the funnel. So you can see the funnel now coming up in the diagram. So funnel will be exactly aft of the binnacle. The resultant is slightly towards the port quarter. So that simply tells us that there has to be a vertical structure on port side of the compass or port side of the binnacle. You can see a vertical structure now coming up towards the port side of the binnacle. So the resultant of this vertical structure and the funnel falls in the direction of the red arrow, and this resultant is what is our Flinders bar correcting. So that brings us to the answer of the first part of the question. The first part answer basically is that the Flinders bar is slewed when IC, induced C, is also present along with IB, induced P. So that tells us that there is a vertical structure on the port side of the compass. Any vertical structure to port or starboard of the compass generates induced C. So this is the analysis for the first part of the question. Now the second part of the question says, what would have been the ship's heading on which the maximum deviation occurred prior to the Flinders bar correction? The meaning of this question, part B, is that we have seen that the resultant of IB and IC, funnel and the vertical structure, lies in this particular direction, in the direction of the red arrow. Now, what is the heading on which this resultant would cause maximum deviation? Any doubts up to here, beta?
So one thing, sir, like funnel, if it is repelling, then magnet is affecting. So वो जो induced magnetism है, it could be attracting also, ना? Like vertical structure on the port side, it is repelling northern. It could be attracting on the eastern, if any structure on the east side.
ओके बेटा, ओके, आई गॉट इट. फनल के टॉप पे रेड या ब्लू कोई भी पोल बन सकता है. इसी
Yes, sir,
तरह
बस
से
यही सवाल है.
वर्टिकल स्ट्रक्चर के टॉप पे रेड या ब्लू कोई भी पोल बन सकता है, पर जो भी पोल बनेगा दोनों पे सेम बनेगा बेटा, बिकॉज बोथ आर मेड बाय द अर्थ्स मैग्नेटिज्म, अर्थ्स मैग्नेटिक फील्ड. सो जो भी पोल इन दोनों के ऊपर बनेगा, फनल पे और वर्टिकल स्ट्रक्चर पे, द सेम पोल विल बी फॉर्म्ड ऑन द फ्लिंडर बार ऑल्सो. सो अगर फनल और वर्टिकल स्ट्रक्चर अट्रैक्ट कर रहे हैं या ब्लू पोल बन रहा है, तो फ्लिंडर बार के टॉप पे भी ब्लू बनेगा, विच विल कैंसल आउट द इफेक्ट. अगर इन दोनों पे
Yes,
रेड
sir.
बन रहा है तो फ्लिंडर बार के ऊपर भी रेड बनेगा, अगेन कैंसलिंग आउट द इफेक्ट.
Yes, sir, because it is also induced magnetism.
करेक्ट, दैट्स राइट.
Thank you, sir.
क्लियर?
सर
ओके,
वन
बोलो बेटा.
सर आपने वर्टिकल स्ट्रक्चर बीम पे बनाया है और फनल आफ्ट पे है, ठीक है सर.
राइट.
तो ऐसा भी हो सकता है कि रिजल्टेंट 15 डिग्री है तो वर्टिकल स्ट्रक्चर बीम से पीछे हो, बीम पे ना
इट
हो
इज पॉसिबल, इट इज पॉसिबल. ये वर्टिकल स्ट्रक्चर बेसिकली शिप के पोर्ट साइड में कहीं पर भी हो सकता है, ऑन द पोर्ट बाव और ऑन द पोर्ट क्वार्टर, किसी भी डायरेक्शन में हो सकता है. ओनली थिंग वी नो इज कि इनका जो रिजल्टेंट है वो 15 डिग्री ऑफसेट हो रखा है. सो डिपेंडिंग अपॉन द साइज एंड लोकेशन ऑफ द वर्टिकल स्ट्रक्चर देयर कैन बी इनफाइनाइट कॉम्बिनेशंस. बट एक्सप्लानेशन के लिए अगर हम इसे किसी ऑब्लिक डायरेक्शन में लेंगे, पोर्ट बाव में या स्टारबोर्ड, सॉरी, पोर्ट क्वार्टर में लेंगे, द एक्सप्लानेशन इज गोइंग टू बिकम लिटिल ट्रिकी एंड कॉम्प्लिकेटेड. उसमें एक तो आप फनल के इफेक्ट को या तो एनहांस करोगे या फनल के इफेक्ट को काउंटर एक्ट करोगे, और फिर ईस्ट वेस्ट का उसका इफेक्ट जो है उसे भी कंसिडर करोगे. सो नो नीड टू मेक इट कॉम्प्लिकेटेड. यू टेक ए सिंपल केस ऑफ हैविंग द स्ट्रक्चर ऑन द बीम. गॉट इट बेटा?
ओके सर.
Great. Let's move ahead. Now, for any magnetic force to cause maximum deviation, it should act at right angles to the magnetic needle. You can see it here also. Maximum deviation because of any force or magnetic field occurs when that force, in our case the resultant of IB and IC, which is the red represented by red arrow. So maximum deviation occurs when this resultant acts at right angles to the compass needle or at right angles to the magnetic lines of force which run in the north-south direction. You can also represent it in this way, that the maximum deviation would occur when the resultant should lie exactly east or exactly west of the compass. So if we take the ship on such a heading that this resultant goes to exactly east or west of the compass, that is the heading on which the maximum deviation would occur. So let us see that now. The first option of bringing this resultant to port or starboard of the compass is that if the resultant moves in the direction of the yellow arrow by this much of an angle, it would come exactly west of the compass needle. Now the angle represented by this yellow arrow is 75 degrees. You see the flinder bar was slewed 15 degrees. So the remaining angle between the stern of the ship and the port beam of the ship is 75 degrees. So the resultant would come in direction west of the compass if we swing by 75 degrees in the clockwise direction. That basically means that if the ship alters its course to starboard by 75 degrees, you can see this green color arrow representing a 75 degree starboard alteration. That is the heading on which the resultant will be at right angles to the compass needle, right angles to the magnetic lines of force, and it will generate maximum deviation. And this heading will be 075 degrees. So this is one option. Now there is one more possibility of bringing the resultant to east or west of the compass. Instead of bringing it to west of the compass, we can also bring it to the east of the compass. Now to bring the resultant east of the compass, the resultant has to move in the direction of this new arrow, yellow color arrow now, which represents 105 degrees. So if the ship changes its heading or swings in the anti-clockwise direction by 105 degrees, this resultant is going to come exactly east of the compass, exactly east of the binnacle. And that tells us that if we do a alteration of 105 degrees to port represented by the red color arrow, if we do a alteration of 105 degrees to port, the resultant would be exactly east of the compass needle at right angles to the magnetic lines of force, generating maximum deviation. Now, if you swing 105 degrees to port, the heading will be 255 degrees. So the second heading is 255 degrees. If the ship heads on 255 degrees, resultant will be exactly east of the compass, generating maximum deviation. So beta, any doubts coming now?
Sir, this easterly westerly deviation heading render bar is 015, sir. And if we do 090, so we have altered 75 degree to the starboard side. But while on the port side, which is westerly, when we are doing, why on 355, sir? To bring 270, we have altered 105 degree to the port side.
Beta, right now the ship is on 000. If you swing to port by 105 degrees, it will be 255, na?
Yes, sir. And then for if we swing it to the starboard side, sir, then it should be?
It should be 075. 075 बेटा, हमें रिजल्टेंट को ईस्ट और वेस्ट में लेके आना है बेटा. ये रेड एरो को ईस्ट या वेस्ट में लेके आना है.
क्लियर सर.
क्योंकि रिजल्टेंट जब ईस्ट और वेस्ट में आएगा तभी तो कंपास नीडल के परपेंडिकुलर होगा और मैक्सिमम डेविएशन जनरेट करेगा.
यस
क्लियर बेटा?
यस.
Okay, great. So you see, this is a little tricky question. If you are not clear about the basics, this question is difficult to get and solve. So I'm going to close down the presentation now, going back to coefficients.
Excuse me, sir.
बोलो बेटा.
सर इसमें अगर वेसल को स्टारपोर्ट 75 प्लस 90 165 रिलेटिव डायरेक्शन में करे तो तब भी वो उसमें आ जाएंगे ना, अबीम हो जाएंगे कंपास में.
नहीं बेटा, अबीम नहीं होगी. मैं बताता हूँ, अगर आप 75 डिग्री स्टारबोर्ड स्विंग करते हो तो ये जो रेड वेक्टर है ये कंपास के वेस्ट में पॉइंट करेगा. अगर आप 90 डिग्री और स्विंग करोगे तो ये रेड वेक्टर कंपास के नॉर्थ में आ जाएगा and it will generate zero deviation there.
Okay, sir. Okay, sir.
ओके
Copy. Correct.
ओके ग्रेट
सर
बोलो बेटा
सर जी आपने ये फ्लिंडर्स बार 015 आपको कैसे समझा कि ये स्टार्बट में ही होना चाहिए? क्वेश्चन में तो कहीं नहीं लिखा है।
बेटा रीड द फोर्थ लाइन
नहीं 015 is okay sir, but it should
ओके
be on the starboard. Why it can't be on the
ओके
port side? 15 degree
बिकॉज
on
बेटा
port.
it is given in three figure notation and the relative bearings are measured clockwise
Okay sir. Okay sir.
ओके अगर वो हमें 15 डिग्री पोर्ट बोलना चाहते तो दो तरीके से बोल सकते थे या तो वो यहाँ पे ही लिख देते 15 डिग्रीज टू द पोर्ट तो हमें 15 डिग्रीज पोर्ट पता चल जाता या अगर 15 डिग्री पोर्ट की वो थ्री फिगर नोटेशन में बताते तो दे वुड से इट इज फिटेड एट ए रिलेटिव डायरेक्शन ऑफ 345
3 4 5 हाँ जी हाँ
राइट
सर
सो
समझे सर
देन वी
3
विल
फिगर
फिट द
नोटेशंस में
राइट दैट्स करेक्ट
हाँ
ओके ग्रेट बेटा
Sir, uh,
हाँ बोलो
sir,
बेटा
since this question has come in MMD as you have shown, and 15 and 10 marks are allotted to each part. So for writing the answer for this, for 15 marks, how much we have to write? I mean, we cannot just write one statement, right? Okay,
ओके
IB and IC is induced, and Flinders bar is
ग्रेट बेटा
corrected.
ग्रेट आई विल टेल यू अब देखो आपको इसका पता तो चल गया है कि इसका आंसर क्या है यू कैन राइट इट इन योर ओन वर्ड्स नाउ मैंने बोलने में अबाउट 15 एक मिनट लगाए होंगे एटलीस्ट 10 to 15 मिनट्स सो इन योर ओन वर्ड्स यू कैन एक्सप्लेन इट एंड मेक दिस डायग्राम मेक द डायग्राम एज वी हैव डन एंड एक्सप्लेन इट अब एक्सप्लेनेशन कितनी करनी है नाउ दिस इज ए क्वेश्चन विच कैन अराइज इन एनी पेपर एनीवेयर कि अगर हमारे पास लेट अस से 15 मार्क्स का क्वेश्चन है तो कितना लेंदी लिखें कितना उसमें हम लोग आंसर लिखें ऑलवेज रिमेंबर बेटा ए थंब रूल कि जितने भी मार्क्स का क्वेश्चन हो उतने पॉइंट्स जो पेपर चेकर है वो एक्सपेक्ट करता है इफ इट इज ए 15 मार्क क्वेश्चन ही इज एक्सपेक्टिंग 15 लाइंस और 15 पॉइंट्स और 15 कीवर्ड्स सो दिस इज ए थंब रूल अगर आप कोई भी पेपर में देखोगे तो आप पेपर का टाइम अगर देखोगे ना the time which is given, number of minutes which are available to you, the total marks will be close to that value. जैसे हमारा ये जो पेपर है दिस इज 3 hours 180 minutes और हमारे मैक्सिमम मार्क्स हैं 200 सो क्लोज टू ईच अदर सो द फंडामेंटल बिहाइंड इट इज that in 1 minute you should be able to write one sentence for which you should get 1 mark. Okay, so that is how the checking goes. So always keep this at the back of your mind when you are answering. Do not write too much and do not write too less.
Okay, sir. Copy. Thank you.
Okay, great. So अब देखो बेटा ये ऐसे क्वेश्चंस हैं कि इनमें अगर फंडामेंटल क्लियर ना हो तो फिर क्वेश्चन बिल्कुल ऊपर से ही चला जाएगा. So this is why I spend a little bit more time understanding of the fundamentals. So now you will start to see the questions coming up and the fundamentals clear, they will start to make sense. So let us now go into our next coefficient. अब हम delta पे चल रहे हैं. So I'm putting on the delta presentation now. Our next coefficient now is coefficient D, coefficient delta. Coefficient D is the maximum value of quadrantal deviation. Now this is the first difference which you see in this particular deviation. It is a quadrantal deviation. Coefficient Bravo and Charlie which we saw were semicircular deviation. This one is a quadrantal deviation, meaning every quadrant or every 90 degrees it changes its sign from east to west or west to east. And it varies proportional to sine of twice the compass course or sine of 2 into compass course. It is caused by a horizontal field due to induced magnetism in horizontal soft iron situated symmetrically about a 4.5 line through the compass. Now this coefficient is entirely generated by induced magnetism. There is no contribution of permanent magnetism in this coefficient. It is generated only by induced magnetism. We have seen induced magnetism was responsible for coefficient A also, but in that case, it was not symmetrical soft iron. It was unsymmetrical soft iron. If it was present forward of the compass, it was not present aft. If it was present on port side of the compass, it was absent on the starboard side. Whereas in this coefficient, you see it is situated symmetrically about a fore and aft line through the compass. The induced magnetism also resulted in IB and IC, but in both these cases, we had the vertical soft iron, forward or aft or port or starboard of the compass. In this case, it is not the vertical soft iron, but the horizontal soft iron which generates coefficient delta. Moving ahead now.
सर क्वाड्रेंटल डेविएशन क्या बताया था आपने?
बेटा every quadrant it will change its name. अगर नॉर्थ ईस्टर्ली हेडिंग पे ये ईस्ट है तो साउथ ईस्टर्ली हेडिंग पे ये वेस्ट हो जाएगा.
ओके सर.
ओके, अभी देखेंगे हम when we go to the deviation. Now let's go into the generation or the cause of the coefficient D. Generally, HSI, horizontal soft iron structure on merchant ships are transverse beams and fore and aft longitudinals or girders. Now, out of these two, the transverse beams are much more in number. They are present in the length profile of the ship, which is much more as compared to the breadth profile of the ship. The fore and aft longitudinal are present in the breadth profile. So transverse beams are much more in number as compared to the longitudinals. And also the ends of the transverse beams are much closer to the compass, making their effect much more predominant. Now the first thing to appreciate here is that if we have a transverse beam and if we have a fore and aft longitudinal exactly similarly placed about a compass having the same size, then they are going to cancel out the effect of each other. If they are perfectly balanced, equal to each other, they are going to cancel out each other. Now that is not the case. The transverse beams are much more in number, and secondly, their ends are closer to the compass location. The ends of the fore and aft longitudinal are close to the bow and stern of the ship, which are far away from the compass location, whereas the beams stretch over the entire length of the ship and the ends of the beam are closer to the compass location as compared to the longitudinals. So number one, the beams are much more in number, and number two, their ends are closer. So thus making the effect of the athwartship beam or transverse beam much more predominant as compared to a fore and aft longitudinal. So in our example, when we understand the deviation generated by coefficient D, we will be assuming one athwartship beam, a horizontal soft iron, and getting or understanding the deviation from there. Moving ahead now. Let's now analyze the deviation diagram for coefficient D. So we have a ship here, and in this ship we have represented one athwartship beam. As we just discussed that their effect is much more predominant as compared to the longitudinal. So we are assuming a athwartship beam here on the ship. We have the compass needle. So you can see the red end of the compass needle pointing towards north and the blue end of the compass needle pointing towards the south direction. So let's now first concentrate on the northerly heading. The vessel is on a northerly heading in this diagram. Now when the ship is heading north, this athwartship beam is at right angles to the magnetic field lines of the earth. The magnetic field lines are running from south to north, and this beam is lying in the east-west direction, perpendicular to the earth's magnetic field. Now since it is perpendicular, there is no induction or almost zero induction which happens on the beam. If there is no induction, no poles are generated, and if there are no poles, no deviation is generated. So the deviation generated on northerly heading is 0. Let's now take the ship on a easterly heading. So in this part of the diagram, you see the vessel heading in a easterly direction. Now with the ship heading on a easterly direction, this outward ship beam is now perfectly aligned with the magnetic field of the Earth. Since it is perfectly aligned, it will have the maximum induction caused because of the Earth's magnetic field. The magnetic field lines will be entering from the south end or the starboard end of the beam, and they will be coming out from the north end or the port beam end of the outward ship beam. The magnetic lines of force entering from south generate a blue pole. So we have a blue pole south of the compass needle, and we have a red pole north of the compass needle. Now these blue and red poles are exactly south and north of the compass needle. Being exactly aligned with the compass needle, they are not able to generate any deviation at all. Because for generating a deviation, the pole has to be at some angle to the magnetic field line or to the compass needle. In this case, it is perfectly aligned. Even though the poles are most powerful in this case, they are still not able to generate any deviation because these are aligned with the compass needle. So the deviation generated is again nil. Zero deviation is generated. Now let's take the ship on a northeasterly heading. Now with the vessel on a northeasterly heading, you see the outward ship beam is partially aligned with the magnetic field of the Earth. It is at a 45-degree angle to the Earth's magnetic field. Now being partially aligned, the poles which are generated, they are partially powerful. They are not at their maximum power. They have partial power. But at the same time, these poles are at a 45-degree angle to the compass needle. Thus, they are able to generate a deviation here. The red pole which you see, which is on the port side of the ship, this red pole is towards the northwest of the compass needle. And this red pole repels the red pole of our compass needle, thus generating a easterly deviation. Likewise, if you pay your attention to the blue pole is southeast of the compass needle, and this blue pole repels the blue end of the compass needle, thus assisting in generating easterly deviation. So easterly deviation is generated in this case with the vessel heading in the northeasterly direction. Now this deviation which is generated here is the maximum easterly deviation. Why it is maximum? You can easily understand it. If the vessel changes its heading and moves toward the northerly heading, as it moves toward the northerly heading, you will see that the outward ship beam is lesser aligned with the magnetic field of the Earth. It is slowly approaching a 90-degree angle to the Earth's magnetic field line, and thus the power of these poles which are generated keeps on reducing. The outward ship beam angle to the magnetic field line keeps on increasing, thus reducing the induction and the poles becoming weaker and weaker. Because of the poles becoming weaker, the deviation keeps on reducing. Now, if the vessel swings to the starboard side and tries to approach the easterly direction, the poles are becoming stronger, but these poles are now coming in line with the magnetic needle. Now, as they come in line with the magnetic needle, they are not able to generate that much deviation, and the deviation starts to decrease. So maximum deviation is caused on the northeasterly heading, and zero deviation is caused on northerly heading as well as easterly heading. Now you can appreciate here the deviation is proportional to sine of twice the compass course. When the heading is 0, 2 into 0 is 0 again, sine of 0 is 0. therefore 0 deviation. When the heading is 45 degrees, 2 into 45 is 90. Sine of 90 is 1, which is the maximum value, generating maximum deviation here. And when the vessel is heading in the easterly direction, heading is 90, 2 into 90 is 180. Sine of 180 is again 0, thus giving us a 0 deviation. So two things which we realize here. One, the deviation is proportional to sine of twice the compass course. Second, the deviation is quadrantal. You see, over one quadrant, it was 0 on the northerly heading, became maximum easterly on the northeast heading, and became 0 again on the easterly heading. Going further, if the ship swings to a southeasterly direction, we will see here that the deviation which is generated is of opposite name now. We have a westerly deviation generated here. So you can see these four quadrants showing the deviation generated, and it tells us that this is a quadrantal deviation. Now the same principle can be applied to any of the other headings, and you can appreciate the deviation being generated proportional to sine of twice the compass course. Now another important thing here is that the directive force in this case is never increased on any heading. You can check all the headings. The directive force is not affected on some of the headings. Yeah, like you see on northerly heading, there is no effect on the directive force. Whereas on northeasterly, easterly, and southeasterly headings, the directive force is decreased. So why is this decreased? This is decreased because the blue end of the beam is aligned south of the compass needle, where we have the red end of the earth. Since the pole of the beam is opposite in direction or opposite in polarity to the pole of the earth, it reduces the directive force.
सर दिस लास्ट लाइन एक बार फिर से रिपीट
Sir,
कर
please
पाते
can you repeat the last sentence?
ओके बेटा, लास्ट में मैंने बेटा ये बताया कि ये ऐसा कोफिशिएंट है जिसमें एवरी हेडिंग पे या तो डायरेक्टिव फोर्स अनअफेक्टेड है या डिक्रीज हो रही है. नोवेयर इज द डायरेक्टिव फोर्स इंक्रीजिंग. अभी तक हमने जितने भी कोफिशिएंट्स किए उनमें कहीं पे डीएफ डिक्रीज हो रहा था, कहीं पे इंक्रीज हो रहा था, बट इन दिस कोफिशिएंट द डायरेक्टिव फोर्स इज ऑलवेज रिड्यूसिंग.
सर बट 045 पे तो इट इज इंक्रीजिंग ना सर इन कोफिशिएंट
बेटा
ऑफ
डायरेक्टिव फोर्स
कॉपीड सर डायरेक्टिव फोर्स एंड
ओके
सर जैसे नॉर्दर्ली एंड साउदर्ली हेडिंग पे सर कुछ
राइट.
भी इसलिए नहीं लग रहा है क्योंकि बीम गर्डर्स तो उनकी चौड़ाई कुछ भी नहीं होती इस वजह से कि इसलिए
नहीं बेटा, नॉर्थ और साउथ हेडिंग पे पोल्स बिल्कुल जनरेट नहीं हो रहे हैं. उसका रीजन ये है कि हमारे जो बीम हैं, these are at right angles to the Earth's magnetic field. Earth's magnetic field is north-south, and these are at right angles, and these are soft iron structures. अगर soft iron structure magnetic field के perpendicular हो जाए तो induction zero हो जाती है.
अंडरस्टूड सर
सर ये
Clear बेटा?
डिक्रीज
हाँ.
क्यों हो गया है थोड़ा बता देंगे.
कौन सी हेडिंग पे
लास्ट में
बताऊं
वर्ड
बेटा? पिक ए हेडिंग ऑफ योर चॉइस.
सर नॉर्थ ईस्टर्ली हो गया तो सर इसमें डीएफ
ओके
डिक्रीज क्यों हो रहा है?
ओके बेटा.
रीजन फॉर दिस.
नॉर्थ ईस्टर्ली हेडिंग पे अगर आप ध्यान से देखो, जो ब्लू पोल बन रहा है हमारे ऑथवर्ड शिप बीम पे, इज दैट ब्लू पोल साउथ ऑफ द कंपास और नॉर्थवर्ड्स ऑफ द कंपास?
नॉर्थवर्ड ऑफ द कंपास.
बेटा ब्लू पोल कंपास के मिडल से देखो, कंपास के मिडल से साउथ की तरफ है या कंपास के नॉर्थ की तरफ है?
साउथ की तरफ से.
अब अर्थ के साउथ में होता है रेड पोल और कंपास के साउथ में बन रहा है शिप का ब्लू पोल. Whenever these
Yes,
poles
yes.
are opposing, the directive force will certainly reduce.
Okay, sir.
Clear? चलें आगे?
Yes, sir.
Great, beta. Let's go. Let us now see the correction of coefficient D. Coefficients are always corrected on the heading on which they produce maximum deviation. In this case, maximum deviation is generated on intercardinal headings: northeast, southeast, southwest, and northwest. So for coefficient D, the correction can be made on any of the intercardinal headings. Basic principle followed in correcting a compass is to cure like with like. That is, permanent deviation is cured with permanent magnets and induced deviation is cured with induced magnetism. In the case of coefficient D, since it is generated because of soft iron structures because of induced magnetism, the correction is also done using a soft iron corrector. So let's see the correction now. Since there is predominance of outwardship beams and also their ends are closer to the compass, these have much more effect than the 4.5 longitudinals. This effect is corrected by providing two soft iron spheres placed one on either side of the compass in the outwardship plane. This will become all the more clear with the help of a diagram. So we will discuss this correction using a diagram. As we just now discussed, the correction is done on any one of the intercardinal heading where the deviation caused due to coefficient D is maximum. In the unlikely event of a ship having more longitudinals than the outwardship beams, and the longitudinals becoming more powerful as compared to outwardship beams, the spheres will be placed fore and aft of the compass. Now, this could be very rare on some special type of ships where the structure of ship is such that the longitudinals are more in number as compared to the beams, and also their ends are closer to the compass. Let's now try to understand the coefficient T correction offered by the soft iron spheres. So let's have the ship in our diagram. You see the ship heading on a northeasterly direction. So why is the ship heading in the northeasterly direction? That's because all the coefficients are corrected on the heading where they are the strongest. So we know coefficient D is the strongest on intercardinal headings. That's why we have chosen a intercardinal heading, and that is northeast. Let's now show the magnetic compass on our ship. You can see the compass coming up. The compass needle is visible on the screen now. The north end of the compass needle having red polarity and the south end of the compass needle having the blue polarity. Any doubts up to here?
Yes, sir. Sir, we could have taken the northwestern heading as well, no? There also the deviation is maximum.
Yes, you can take any one of the intercardinal headings, beta. Any one.
Okay, sir. Clear.
Okay. Let's now show the outwardship beam. Now this is the soft iron structures, a outwardship beam, which is responsible for generating coefficient D, coefficient delta. Now, since this beam is a soft iron structure, it does not have any permanent magnetism or any permanent poles. The magnetism in this beam is induced magnetism, and it is generated by the magnetic field of the Earth. So let's now show the poles of the Earth in our diagram. You can see the south pole of the Earth coming up on the screen at the bottom, and it is having a red polarity. And we can now see the north pole of the Earth, north magnetic pole of the Earth coming up at the top of the screen, having a blue polarity. Let's also show the magnetic lines of force in our diagram. We are aware that the magnetic lines of force, they come out of the red pole and they enter or they go towards the blue pole of the Earth. So you can see the magnetic field lines shown by These arrows, the magnetic field lines, are generating from the south pole of the Earth, the red pole, and they are going into the magnetic north pole, the blue pole of the Earth. Now these magnetic lines of force will be inducing the athwartship beam present on the ship. Now the starboard end of the beam is the point where these magnetic lines of force are entering, and we are aware that wherever the magnetic lines of force enter, they generate a blue polarity. So you can see a blue pole being generated at the starboard end of the soft iron athwartship beam. Now the port side end of the athwartship beam is the point where the lines of force are leaving or going out of the beam, and wherever the lines of force go out, they generate a red pole or a red polarity. So that's why you can see a red pole being generated at the port end of the athwartship beam. Now these red and blue poles generated at the end of the beam are the ones which are causing coefficient D, which are causing the deviation in our compass. The red pole on the port end of the beam is repelling the north end of our magnetic compass needle. Red and red, they repel each other, and the needle turns clockwise. Looking from top, the needle turns clockwise or in the easterly direction, generating a easterly deviation. Likewise, you see the blue pole, which is generated on the starboard end of the athwartship beam, repels the south end of our compass needle, both having blue polarity, blue repelling blue, and again complementing the easterly deviation. So the compass needle turns clockwise, looking from top of the compass, and it generates a easterly deviation. Now for correcting this deviation, we use the principle of like cures like. So we correct it using a soft iron corrector. And in this case, we use soft iron spheres. So let's place the spheres. You can see the spheres now coming up on the sides of the compass in the athwartship direction. There is a sphere on the port side of the compass, and you have the second sphere on the starboard side of the compass. Now these are soft iron spheres, so they also do not have any permanent poles. These spheres will also be induced by the Earth's magnetic field lines. The end of the sphere where the magnetic field lines enter will get a blue polarity. So you see the south end of the sphere. Let's first concentrate on the starboard side corrector, starboard side sphere. You see the south end of the sphere right now where the laser pointer is the point where the magnetic lines of force are entering and thus generating a blue polarity in that direction. The top end or the north end of the sphere is the point where the magnetic field lines are leaving or going out from the sphere, thus generating a red polarity. Similarly, if you have a look at the port side sphere, the bottom end where the laser pointer is right now is the one where the magnetic lines of force are entering, giving it a blue polarity. And you can now see the points where the magnetic lines of force are leaving or coming out from the spheres, they are having a red polarity. So we have the corrector spheres placed in the athwartship direction of the compass to port and starboard of the compass. And we have these corrector spheres induced by the Earth's magnetic field. Points where the Earth's magnetic field lines are entering into the spheres have got blue polarity, and the points where the magnetic lines of force are coming out of these soft iron spheres have got a red polarity. Any doubts up to here, beta?
सर एक डाउट था यहाँ पे.
बोलो बेटा.
पहले जो सर हम लोग करेक्टर्स यूज कर रहे थे, दे वे आर नॉट गेटिंग अफेक्टेड. मतलब करेक्टर्स जो होता था उसमें कुछ इंड्यूस्ड मैग्नेटिज्म का इफेक्ट नहीं रहता था, बट हम लोग यहाँ पे करेक्टर्स भी इफेक्ट हो जा रहा है क्या? इसके लिए हम लोग ये दिखा रहे हैं.
बेटा हमने जहाँ कहीं भी सॉफ्ट आयरन करेक्टर यूज़ किए हैं वहाँ पे इंड्यूस्ड मैग्नेटिज्म जनरेट हुआ है। आईबी में हमने फ्लिंडर बार लगाई थी, दैट वाज ए सॉफ्ट आयरन रॉड। उसमें अर्थ के मैग्नेटिज्म की वजह से तो पोल बना था बेटा।
ओके सर, क्योंकि हमने जो लास्ट किया था तो उसमें हम लोग का करेक्टर्स जो हम लोग यूज कर रहे थे दैट फिल्टर बार, उसमें वो मैग्नेटिज्म की वजह से इफेक्टेड नहीं हो रहा था जैसे जो देखा
बेटा फ्लिंडर बार में अपना तो कोई मैग्नेटिज्म नहीं है और वो वर्टिकल है, तो वो अर्थ के फील्ड की जो वर्टिकल डायरेक्शन है उससे मैग्नेटाइज हो रहा है, इंड्यूस्ड मैग्नेटिज्म से।
बट सर जो मैंने
अदरवाइज जो
लास्ट में
फ्लिंडर अदरवाइज जो फ्लिंडर बार है वो तो सॉफ्ट आयरन है बेटा, उसमें तो अपने कोई पोल्स ही नहीं होंगे।
ओके सर, हम लोग सॉफ्ट आयरन यूज कर रहे थे इसके लिए नहीं हो रहा।
एग्जैक्टली exactly. जो पीबी और पीसी हैं वहां पे हमने परमानेंट मैग्नेट यूज किए थे। परमानेंट मैग्नेट्स को अर्थ के मैग्नेटिज्म से कोई फर्क नहीं पड़ता है, उनके पोल्स परमानेंट होते हैं। गो अहेड बेटा।
Sir, any specific reason why we are using only spears? Why not using a Flinders bar again?
Okay, the simple reason is it's the most regular geometric shape and it will present the same face to the compass in any list, trim, rolling, pitching condition.
Okay, sir. So, but in case of Flinders bar also, it should be applicable. No, then why didn't they place the spear forward? I mean, is there a
Okay.
specific reason?
The reason for that is because if you place a sphere in place of the Flender bar, that sphere, if it is placed, it will have both the poles and it will not be able to make any correction. It was correcting a VSI, so it had to replicate a VSI.
Okay, but it is also creating poles, no, sir? The Flinders bar.
Flender bar is creating what?
Poles?
Yeah, it is creating poles, but you see Flender bar का जो top pole है वही compass के पास है बेटा. The bottom pole of the Flender bar is far away, so bottom pole does not affect. अगर आप उसकी जगह एक स्फीयर लगा दोगे तो दोनों पोल स्फीयर के बिल्कुल कंपास के पास ही बनेंगे and they will not do the correction.
Okay, sir. Yes.
Okay.
सर ये शिप का डायरेक्शन जैसे जैसे चेंज होगा तो ब्लू और रेड पोल की पोजीशन घूमती रहेगी स्फीयर पे, राइट सर?
बिल्कुल सही है बेटा, ब्लू और रेड की पोजीशन भी चेंज होती रहेगी. Okay, let's move ahead. Now let's first concentrate on the starboard corrector sphere. Now the starboard corrector sphere is having both the magnets, both the poles. You have the red pole as well as you have the blue pole. Now that pole of the corrector affects the magnetic compass which is closer to the compass. Now out of this red and blue pole of the starboard corrector, the pole which is closer to the compass is the red pole. So from the starboard corrector, red pole is what is affecting the compass. And this red pole is going to attract the south end of the compass towards it, thus cancelling out the easterly deviation. When the red pole of the corrector magnet, the starboard corrector magnet, attracts the south end of the compass needle, south end has a blue polarity, opposite poles attract. So when it attracts the south end, the compass needle turns anti-clockwise, thus cancelling out the deviation generated. You can see the starboard end of the beam was having a blue polarity, whereas the starboard soft iron corrector having a red pole closer to the compass is cancelling the effect of the outwardship beam. Now let's take our attention to the port side corrector. Now in the port side corrector, we are having both the poles, blue pole as well as the red pole, but the pole which is closer to the compass needle is the blue pole. The blue pole is closer to the compass needle, and this blue pole attracts the north red end of our magnetic compass needle. North end of the compass needle having a red polarity, corrector magnet pole closer to the compass having a blue polarity, blue and red being opposite poles attract each other, This also leads to the magnetic needle swinging anti-clockwise looking from top, thus cancelling out the deviation generated. You can also have a look at the end of the authwardship beam. The end of the authwardship beam was having a red polarity deviating our compass, and the corrector magnet pole closer to the compass has a blue polarity which cancels out the effect of the authwardship beam. So you can now see the corrector magnets, soft iron corrector magnets placed in the authwardship direction, cancelling out the deviation generated because of the ends of the authwardship beam. Any doubts in this, beta?
सर जस्ट एक बार फिर रिपीट बता देंगे सर. नॉर्दर्ली साउदर्ली में it was not generating because induced current is not affecting the beam.
Okay, let me take you back to the deviation diagram, beta. ये देखो बेटा, नॉर्थ और साउथ हेडिंग पे जो हमारा ऑथवर्डशिप बीम था उस पे इंडक्शन नहीं हो रही थी बिकॉज द बीम वाज एट राइट एंगल्स टू द अर्थ्स मैग्नेटिक फील्ड, सो नो पोल्स वर जनरेटेड, नो डेविएशन इज देयर.
Copied. And sir,
Okay.
this induced magnetism, जो ये sphere वाला diagram इस पे आ जाएंगे सर वापस.
Sphere वाला diagram, okay, here it is.
Like sir, अब ये हमारा beam है सर जिसमें southerly blue pole बना, but
Right.
it will be जैसे like currents वो यहाँ पे जैसे blue है सर, हम लोग sphere लगाए तो
Right.
this blue will be affecting the sphere के भी blue पे affect करेगा ना सर उसके.
नहीं बेटा, जो हमारे ऑथवर्डशिप बीम के पोल्स बन रहे हैं, दीज पोल्स आर मच मच वीकर. ये पोल्स आपके करेक्टर स्फीयर को अफेक्ट नहीं करेंगे. करेक्टर स्फीयर को अर्थ का मैग्नेटिक फील्ड इफेक्ट करेगा, क्योंकि इन सब की जो जनरेटिंग फोर्स है वो तो अर्थ का मैग्नेटिक फील्ड है ना.
Yes sir.
So Earth's magnetic field is much much more powerful than the magnetism generated on the beam.
मेरा डाउट समझे सर, जैसे अगर वो if it is coming from this blue side coming out red, मतलब करेक्टर स्फीयर को सर इफेक्ट उसके मैग्नीट्यूड पे आना चाहिए क्योंकि बीम की वजह से भी तो इफेक्ट आना चाहिए सर.
बेटा, बीम का मैग्नेटिज्म भी अपना मैग्नेटिज्म नहीं है, ये अर्थ के मैग्नेटिक फील्ड की वजह से जनरेट हो रहा है, और ये अर्थ के फील्ड से बहुत कम है, बहुत वीक है. ओके. और लेट अस से अगर वो ये स्फीयर के मैग्नेटिज्म को अफेक्ट कर भी देता है तो बेटा द अदर थिंग इज आल्सो ट्रू ना. स्फीयर्स मैग्नेटिज्म इज आल्सो गोइंग टू अफेक्ट द बीम्स मैग्नेटिज्म.
Yes.
If you think
Yes.
it that way, so both will cancel out each other.
Okay. Yes.
Okay, great. So this was the correction of coefficient delta. Let me explain you a little bit more about these spheres and then we will complete delta. So as we just now discussed, the spheres are fitted on brackets attached to the binnacle so that their centers are in the same plane as the plane of the compass. The magnitude of the correction can be varied by shifting the spheres closer or farther from the compass. So you can see the spheres placed in the outwardship direction. You can see this is the bracket which is fitted. You can see the channel also here. Likewise, on the port side, you have this sphere as well as the channel and the bracket. So on the right side diagram, you can see this is the bracket, the channel. There is a scale here on the channel which helps us to correctly position the spheres at equal distance from the compass. So these are the soft iron sphere correctors placed on the sides outwardship direction, port and starboard of the compass to correct coefficient delta.
Sir, Can we go
Go
back
ahead,
to
beta.
this slide?
Yeah, go ahead, beta.
Sir, in this one, as we can see, the spheres are in the same plane to the needle. So, sir, uh, let's say starboard side sphere is inducing magnet induced by a blue side on the bottom and the red side on top. And the
ओके,
same
दी
will happen.
साइड्स, होल्ड ऑन, ये जो बेटा ब्लू और रेड बनेंगे ये टॉप और बॉटम पे नहीं बनेंगे.
Okay.
ओके, दे विल बी on the aft end and the forward end of the sphere. Okay,
Oh,
they are having a horizontal orientation. They will not be up and down beta.
अच्छा. Okay.
क्योंकि अगर आप अप एंड डाउन वाला, अप एंड डाउन का भी एक पर्टिकुलर इफेक्ट होगा यहाँ पे, बिकॉज अगर आप पोल पे चले जाओगे तो वो अप एंड डाउन इफेक्ट आ जाएगा, पर वो अप एंड डाउन इफेक्ट कोई करेक्शन नहीं देगा. बिकॉज अगर स्फीयर के टॉप पे ब्लू है और बॉटम पे रेड है तो वो दोनों एक दूसरे को कैंसल आउट कर देंगे एंड दे विल नॉट गिव एनी करेक्शन टू द कंपास.
Okay, sir. Okay. So it's like on the forward and aft line, मतलब forward aft line पे.
Right.
Okay.
Yeah, we are
Clear.
basically considering the horizontal positioning of these red and blue poles.
Okay, sir.
Okay, great. So this I have already told you why we are using the spheres. It's the most regular geometric shape, making the correction uniform on all the headings. And this is another diagram where you can see a actual binnacle. The spheres are fitted on both the sides. So this is how the sphere correction is done. So that completes our coefficient delta now, beta. Any doubts about delta?
Sir, can we do maintenance on these spheres? Like many a times we see there is rust on this, so some masters still use emery tape and then remove the rust and all. Is it?
You can, but if you observe that there is already a lot of rust or lot of pitting, so then it is better to change the spheres. Because if the amount of steel differs, amount of steel is not have reduced or it has substantially thinned down, it is better to replace it. But you can do the maintenance. If rust is there, just remove it, but don't remove it with a chipping hammer.
Okay, sir. And how much mm or centimeters from the compass ball you have to keep these spheres?
Okay, you first take it to the maximum outstretched position. Okay, when I do the correction I will tell you, so I will tell you in detail.
Okay.
सबसे पहले इनको ना मैक्सिमम स्केल पोजीशन पे कंपास एडजस्टर रखता है, फिर स्लोली इनको पास में लेके आता है, and when he brings it closer the card changes and he will do only the correction what is required. So मैं बताऊंगा आपको डिटेल में when we do the compass correction tomorrow.
Okay, sir.
सर एक्सक्यूज मी सर, प्रीवियस स्लाइड पे जाएंगे सर, स्पेयर वाले पे.
Okay, this one,
जहाँ पे स्पेयर रेड एंड ब्लू बनाया था आपने.
red and blue. ये रहा बेटा.
सर ये जो है ये आपने सदर्न हेमिस्फीयर में बनाया ना सर.
Any
यदि
hemisphere
हेमिस्फीयर
बेटा.
चेंज होगा तो ये भी चेंज हो जाएगा ना सर.
No. Any hemisphere. We are bothered about the horizontal positioning of the poles in the spheres. हम यहाँ पे देखो बेटा अर्थ का वर्टिकल फील्ड तो कंसिडर ही नहीं कर रहे हैं, हम तो अर्थ का हॉरिजॉन्टल फील्ड कंसिडर कर रहे हैं ना, वो तो हमेशा साउथ टू नॉर्थ ही रहता है. ये जो डायग्राम आप देख रहे हो, दिस इज बेसिकली ए एरियल व्यू ऑफ द शिप. आप एक ड्रोन को शिप के ऊपर ले जाओ और ऊपर से देख रहे हो आप. सो दिस स्लाइड इज शोइंग यू द हॉरिजॉन्टल प्लेन. Getting clear beta?
Forward side of the sphere is red and aft side is blue, correct? Like this, no?
Not the forward. In this case, the port bow end of the sphere is red and the starboard quarter end of the sphere is blue. समझ गया बेटा? ओके, ग्रेट. सो अब बेटा कोफिशिएंट डेल्टा पे भी ना एक इंटरेस्टिंग क्वेश्चन है जो हमारे पेपर में आता है, जिसमें ये स्फीयर्स की भी स्लूइंग होती है. ओके, But before that, we were cover eco. Eco will you can cover very quickly because eco is very similar to delta. Only thing is it is turned by 45 degrees. So let's take a short 5 minutes break and then we come back and cover up eco.
सर आपका आवाज इको आ रहा है. Is it
Because
possible
somebody's
to?
mic is on.
Okay.
Oh, now there will be no echo. So let's go for a 5 minutes break and be back. Okay, beta?
Okay.
All right.
Okay, all right. Bye bye. ये बेटा चले आगे बैक.
Yes, sir.
Okay. So I'm moving on to coefficient eco now. Let's now move on to the next coefficient, which is coefficient E, eco. Coefficient E is very similar to coefficient delta. Very similar to coefficient delta with only one difference. It has, you can assume it has a phase difference of 45 degrees. Coefficient delta was powerful or the strongest on intercardinal headings, and it was 0 on cardinal headings. Whereas coefficient eco is 0 on intercardinal heading and it is maximum on the cardinal headings. So very similar. Coefficient T is the maximum value of quadrantal deviation. It is again a quadrantal deviation which changes its name every 90 degrees, which varies as the cos of twice the compass course. It is caused by a horizontal field at the compass position due to induced magnetism in the horizontal soft iron situated symmetrically about a 45-degree line through the compass position. So for generation of coefficient T, we need to have a soft iron structure on the ship in this particular orientation. You can see a soft iron structure at a 45-degree angle to the fore and aft line or to the outward ship line. So normal merchant vessel will not have any structure like these. The fore and aft longitudinal as well as the outward ship beams are generally the strength members of a normal merchant vessel. So we will not have a substantial structure, a soft iron structure at a 45-degree orientation. And this is exactly the reason why coefficient T is absent in a normal merchant vessel. Or if you have a soft iron structure in this particular orientation at a 45-degree angle, now this soft iron is divided at the compass location. So both these structures are usually absent on normal merchant vessels. Moving ahead now.
Sir,
Go ahead, beta.
sir, like delta induced in outward direction, देखिए eco horizontal plane जब outward direction हम लोग delta में किए सर तो eco क्यों आ रहा है सर मतलब coefficient E क्यों हम लोग ले रहे हैं
Okay, beta. Delta was because of a structure port or starboard of the compass or forward or aft of the
yes
compass. Eco is because of a structure which is neither port starboard nor forward aft. It is at a 45-degree angle to the compass location or to the fore and aft line.
okay sir delta was only in outward ना sir port and starboard
बेटा जो फोर एंड हाफ लॉन्जिट्यूडनल है वो भी डेल्टा के अंदर ही आता है, लेकिन उसका इफेक्ट बहुत कम होता है और आउटवर्ड शिप बीम उसके इफेक्ट को कैंसिल कर देता है.
yes sir तो डेल्टा में हम लोग स्फीयर यूज किए ठीक है हम लोग इको कंटिन्यू करते
बेसिकली जो डेल्टा था ना बेटा उसको हमने 45 डिग्री टर्न कर दिया तो वही कोफिशिएंट इको बन जाता है.
okay sir delta and eco are same thing we can say sir
They are similar to each other. Only thing is delta and eco have 45 degrees phase difference. That's all.
copied sir 45 degree
Okay. Let's now see the deviation generated because of this structure. So let's first have a look with the ship on a northeasterly heading. When the vessel is on a northeasterly heading, this structure is perfectly aligned with the magnetic field line of the ship, thus generating very strong poles at both the ends of the soft iron structure. But these poles are exactly north and south of the compass location, thus generating no deviation at all. For generating any deviation, the poles generated should be at some angle to the north-south line or at some angle to the magnetic field of the earth or to the magnetic needle, and in this case this angle being 0, no deviation is generated. Now let's take the ship on a easterly heading. With the vessel on a easterly heading, we can see that this structure is now partially aligned with the magnetic field of the earth, partially aligned. So the poles generated are of the partial power, but these poles are at a 45-degree angle. This is where maximum deviation is generated by these poles. So on the easterly heading, you see maximum deviation is generated. In the previous case, with the vessel heading in the northeasterly direction, the deviation generated was 0. So on an intercardinal heading, the deviation generated is 0. On a cardinal heading, the deviation generated is maximum. Now let's take the ship on a southeasterly heading. When the ship goes on a southeasterly heading, you see this structure is now at right angles to the magnetic field of the earth. So being at right angles, the induction is 0, negligible, no poles are generated. With no poles being generated, the deviation generated is also 0, so nil deviation on southeasterly heading. So you see 0 deviation on the intercardinal heading and maximum deviation on the cardinal heading. If you look closely, this entire deviation diagram is very much similar to the diagram of coefficient delta, as if the coefficient delta diagram has been rotated by 45 degrees. So that's why I said there is a 45 degrees phase difference between delta and eco. चलें बेटा आगे. Any doubts up to here?
सर सारे कोफिशिएंट समझ में है, लेकिन कोफिशिएंट इको हम लोग 45 डिग्री एंगल पे लिए क्यों सर? जैसे किसी में बीम आप बताए, किसी में लॉन्गिट्यूडनल बताए, इको का किस वजह से हो रहा है सर?
ओके बेटा, डेल्टा के केस में एक ऑथवर्ड शिप बीम था ना शिप पे लगा हुआ.
यस सर.
वो जो ऑथवर्ड शिप बीम शिप पे लगा हुआ था, हमने उसको टर्न कर दिया क्लॉकवाइज बाय 45 डिग्रीज. तो अब आप ध्यान दो, शिप नॉर्थ हेडिंग पे है, आपको एक स्ट्रक्चर दिखाई दे रहा है जो पोर्ट बाव से स्टारबोर्ड क्वार्टर की तरफ आ रहा है.
यस सर.
ये वही ऑथवर्ड शिप बीम है and it has been turned by 45 degrees in the clockwise direction.
तो नॉर्मल शिप्स पे तो ये होते नहीं होंगे ना सर?
बिल्कुल बेटा, नॉर्मल शिप्स पे ये नहीं होते हैं. नॉर्मल शिप्स पे तो हमारे ऐसा कोई स्ट्रक्चर नहीं होता है. दैट इज द रीजन कि नॉर्मल शिप्स पे कोफिशिएंट इको भी एब्सेंट होता है.
कॉपीड क्लियर.
ओके, you can see the deviation represented here. This is the heading of the ship: north, northeast, east, southeast, south, and so on. And the curve shows the deviation generated. Maximum deviation on northerly heading, zero deviation on northeast, maximum deviation in the opposite direction on a easterly heading, zero deviation on southeast, maximum heading in the opposite direction on a southerly heading, and so on. Now moving forward to the correction of coefficient T. As we discussed, on a normal merchant vessel, coefficient T would be absent as there is no substantial structure at a 45 degree angle to the fore and aft line of the ship. However, if it is present, the correction is done exactly similar to coefficient delta using soft iron spheres. But in this case, the spheres are placed diagonally. In the same direction in which the structure lies, the spheres are placed in the same direction. If you remember, we did the same thing in coefficient delta also. The beam in that case was lying in the outward ship orientation, so the soft iron correctors were also placed in the outward ship direction. In case of coefficient E, the structure is at a 45 degree angle, so that's why the corrector are also placed at a 45 degree angle to the fore and aft line. Moving ahead now, beta. So in this diagram, you can see this is the case we discussed in the deviation diagram. We have a structure in this particular way. The soft iron spheres are placed in the same orientation, thus cancelling out the effect of the soft iron structure. Now, in case on a particular ship, coefficient D and coefficient E, delta and eco, both these coefficients are present together. When both coefficient delta and eco are present, they can be corrected by using a single set of spheres. We do not need to use two separate set of spheres. Coefficient delta is corrected by placing the spheres in the outward ship direction. Eco is corrected by placing the spheres at a 45 degree orientation to the fore and aft line. But if both of them are present, they can be corrected using a single set of spheres which are slewed or turned to some intermediate angle in the direction of the resultant of both these coefficients. Now, how do we decide what is the direction in which the spheres should be placed? If it was only delta, the correction, the placement was simple. They need to be placed in the outward ship direction. If it was only eco, the orientation was similar to the structure present on the ship. But if both are present, a single set of sphere can be placed and slewed. The slew angle is calculated by the formula tangent of twice the angle of slew is equal to coefficient eco divided by coefficient delta. So whatever is the magnitude of eco divided by the magnitude of coefficient delta gives us tangent of twice the angle of slew. So angle of slew can be obtained using this formula. Moving ahead now, beta.
सर जो ये
Go ahead,
फॉर्मूला
beta.
समझ तो ये फॉर्मूला जैसे पिछला वाला हम लोग जो किए वो फॉर्मूला आईबी और आईसी का समझ में इसका इको और
Right.
डेल्टा
Okay, beta. If you remember जो हमारा IB और IC वाला फॉर्मूला था, that was tangent angle of slew is equal to IC upon IP, right?
यस
अब बेटा जो डेल्टा और इको कोफिशिएंट है, they are proportional to twice the sine of course and twice the cos of course. That is why this angle of slew also becomes twice. That is why tangent of twice the angle of slew is equal to eco upon delta.
कॉपीड ये कुछ
Okay.
प्रूफ नहीं करना ना हम लोग कभी भी
नहीं
बस
बेटा,
रख
नहीं, कुछ प्रूव नहीं करना है. दिस इज जस्ट फॉर इन्फो. सो इसका प्रूफ वगैरह कुछ नहीं आएगा. आई विल शो यू इस पे किस तरह के क्वेश्चन आते हैं. सो वी विल डू दैट क्वेश्चन.
यस सर
Once the slew angle has been calculated, the spheres are initially placed to correct coefficient delta. For correcting coefficient delta, the spheres are placed in the authorship direction. After correcting delta, the spheres are now slewed by that particular angle. Now, how do we decide whether the spheres are to be turned or slewed in the clockwise direction or the anti-clockwise direction? Practically on board, it is very simple. Once you have placed the spheres in the authorship direction, they should be slewed towards the direction of the structure which is at a 45-degree angle to the fore and aft line. So in whichever orientation the 45-degree soft iron structure is present, the sphere should be slewed towards that structure. Theoretically, it can also be obtained, it can also be found if delta and eco are of the same sign, both are easterly or both are westerly, the spheres are slewed clockwise, and if they are of opposite signs, the spheres are slewed anti-clockwise looking from top. Now, after obtaining the slew angle, after obtaining the direction in which the spheres are to be slewed, the next question which the compass adjuster has to be clear about is, what is the heading on which the ship should be when this combined correction is being done? If it was only coefficient delta, we know the vessel has to be on any one of the intercardinal heading, that is where it is the strongest. If it was only coefficient eco, we know the vessel should be on some cardinal heading, that is where coefficient eco is strongest. But when we are having a combined correction of delta and eco, what should be the heading of the ship? Now for this, the maximum deviation due to delta and eco combined occurs when the spheres lie in the northeast or southwest direction of the compass location. Reason being that any horizontal soft iron will produce maximum deviation when they lie in the northeast, southwest or northwest, southeast of the compass location. Go ahead, beta.
सर लाइक इंड्यूस्ड ऑफ आईबी एंड आईसी जैसे जो भी इंड्यूस्ड थे दे वर हैविंग सेम पोल्स तो डेल्टा एंड इको में सर इफ सेम साइन इनमें भी रहना चाहिए ना सर?
मैं दोबारा से पूछो बेटा।
लाइक सर डेल्टा एंड इको में सर जो इंड्यूस्ड मैग्नेटिज्म जो बना सर, सो
राइट,
आउटवर्ड शिफ्ट और यदि वो डायगोनली हो तो उन दोनों के पोल्स तो सिमिलर होने चाहिए ना सर?
डेल्टा एंड इको के पोल सिमिलर होने चाहिए।
जैसे सर किसी डायग्राम में जाएंगे सर हम लोग
ओके,
पीछे।
ये बेटा इको की डायग्राम आ गई।
ये सर इसमें सर जैसे ब्लू पोल बना शिप के, जैसे नॉर्दर्ली वाला हम लोग ले रहे हैं एंड ब्लू
ठीक है,
पोल
नॉर्थ
बना
हेडिंग, राइट।
नॉर्थ हेडिंग। अब सेम अगर ये नॉर्थ ईस्ट पे है और ये ब्लू
राइट,
बना है सर, और हमारा आर्थवर्ड शिप का भी वो भी तो राइट साइड में ही उसके पास वाला ही नॉर्थ बनेगा,
बिल्कुल बेटा।
मतलब
अगर
ब्लू
आप यहाँ पे
बनेगा।
ऑर्थवर्डशिप बीम लगा दोगे तो ऑर्थवर्डशिप बीम का जो स्टारबोर्ड एंड है वहां पर भी ब्लू पोल बनेगा।
ये सर लेकिन नीचे जो लिखा हुआ था सर कि सेम साइन देन क्लॉकवाइज एंड अपोजिट, तो साइन तो सेम ही रहना चाहिए ना सर?
ओके 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 ओके। नहीं बेटा, इसमें मैंने आपको बताया नहीं है कि हाउ टू कैलकुलेट ए कोफिशिएंट। हर एक कोफिशिएंट को हम लोग कैलकुलेट कर सकते हैं, पता लगा सकते हैं कि डेल्टा का कितना मैग्नीट्यूड है और ये ईस्ट है या वेस्ट है। एंड इसी तरह से इको का भी पता लगा सकते हैं। ये कॉन्सेप्ट जो है ये कंपास करेक्शन के साथ आएगा। सो यू हैव टू जस्ट वेट फॉर सम टाइम। वी विल बी डूइंग द कंपास करेक्शन, देन आई विल एक्सप्लेन यू कि कैसे हम सारे के सारे कोफिशिएंट का मैग्नीट्यूड निकाल सकते हैं। So you
यस
have to see those values of delta and echo. If both are same, that means both are causing easterly deviation or both are causing westerly deviation, तो हम इसे clockwise turn करते हैं।
क्लियर सर?
ओके।
जी सर। यस
एंड प्रैक्टिकली ये बहुत आसान है। प्रैक्टिकली अगर ऑर्थवर्डशिप बीम लगा हुआ है यहाँ पे, तो आपको पता है ऑर्थवर्डशिप बीम भी है और ये 45 डिग्री वाला स्ट्रक्चर भी है, तो स्फीयर्स इन दोनों के बीच में ही कहीं आएंगे because they are
यस सर।
counteracting the effect of both of them. So spheres will be between them.
यस सर।
Okay. ओके, सो अब बेटा ये जो चीज हमने देखी यहाँ पे थ्योरेटिकली, इसको प्रैक्टिकली हम लोग अब देखने वाले हैं। देयर इज ए क्वेश्चन विच कम्स ऑन द करेक्शन ऑफ डेल्टा एंड इको टुगेदर। सो लेट अस सी व्हाट इज दैट क्वेश्चन एंड हाउ दिस कॉन्सेप्ट इज यूज्ड इन आंसरिंग इट। लेट्स गो। ये थोड़ा सा ट्रिकी लग सकता है आपको, बट वी विल गो स्लोली एंड अंडरस्टैंड इट स्टेप बाय स्टेप। लेट्स गो।
जी सर। सर
गो
आवाज आ
अहेड
रही
बेटा।
है?
हाँ, गो
सर
अहेड।
ये प्रीवियस स्लाइड में आपने सेम साइन का मतलब कि दोनों ईस्ट होने चाहिए और दोनों वेस्टर्ली होने चाहिए तब?
दैट्स करेक्ट बेटा, दैट्स करेक्ट।
ओके सर, ओके, थैंक यू सर।
Now let's try to understand the combined correction of coefficient delta and echo, this concept, using a actual question. On a ship, the soft iron spheres are observed to be placed in a relative direction 100 and 280 with respect to the ship's head. Analyze the cause for same and find the heading on which the sphere correction should be done. This is the actual question which has come in the past papers on this particular topic. So let's first try to understand what the scenario is. What does the question mean? Let me show you a diagram. So we see the ship here, and on the ship we have the compass. The circle which you see in the center represents the compass, and the spheres are fitted on this ship. in a relative direction of 100 and 280. This is a relative direction with respect to the ship's head. Let's assume for the time being that the ship is heading north. So this is the north direction as well as the ship's head, and the spheres are lying in a direction 100. So from the ship's head going clockwise up to an angle of 100, this is where one of the sphere lies. And going further, 100, 120, 130, 180, then 270 and 280. This is the direction in which the second sphere lies. So we are now able to see what is the orientation or location of the spheres with respect to the compass. So the first thing they are asking in the question is, analyze the cause for same. Now one thing which becomes clear to us is that on a normal merchant vessel, the spheres are usually placed in the outward ship direction. That means in a relative 090-270 direction. Now that happens when the ship only has coefficient delta. If coefficient eco is present, the spheres will be placed either northwest southeast or northeast southwest of the compass. We are aware that when both the coefficients are present, that is delta and eco, that is the case when the spheres are slewed at a particular angle, and that is the situation here. So this clearly tells us that on this particular vessel, we have coefficient delta as well as coefficient eco. Both these coefficients are present on the ship. And that is the reason why the spheres are slewed. They are fitted at an angle, not in the outward ship direction, but at an angle. Another thing which we observe is, looking from top, the spheres are slewed in a clockwise direction. If you see, they are slewed by an angle of 10 degrees in a clockwise direction. Looking from top, the spheres are turned in a clockwise direction. So this gives us the second inference here, that coefficient delta and coefficient eco are of the same sign. Because we are aware, when delta and eco are of the same sign, the spheres are slewed clockwise. If delta and eco are of the opposite signs, the spheres are slewed anti-clockwise. So that is the second inference which we get. First inference, this ship has coefficient delta as well as eco. Second inference, coefficient delta and coefficient eco are having the same sign. Now going further, we need to find the heading on which the sphere correction should be done on this particular ship. Go ahead, beta.
Sir, sorry, sir. मेरा वो internet connection चला गया था. Sir, can you just explain how delta and echo are having the same sign?
Okay. Now you see, beta, the spheres are turned or slewed clockwise. Normal position of the spheres is outward ship. They have been turned 10 degrees in the clockwise direction. Correct?
Sir, ये तो mention नहीं किया है question में कहीं.
बेटा 100-280 की डायरेक्शन में दिख रहे हैं ना स्फीयर.
अच्छा, okay, clear.
Okay, so 090 से अगर 100 जाओगे, then you have to turn it clockwise.
Correct.
So turning clockwise tells us that delta and eco are of the same sign. दोनों ईस्ट हैं या दोनों वेस्ट हैं.
Okay, sir. Okay, understood.
Okay. अगर यही स्फीयर्स 080 और 260 की डायरेक्शन में होते, then they were turned 10 degrees anti-clockwise, then we will have an inference that delta and eco are of the opposite names.
Yes, okay.
Okay. So moving ahead now. Now always remember the fundamental that whenever we are doing any sphere correction, it may be coefficient delta, it may be coefficient eco, or it may be the combined correction for delta and eco. In all these cases, whenever we are doing any sphere correction, we have to ensure that the spheres are at a intercardinal direction from the compass location. That means the sphere should be either northeast of the compass, or southeast of the compass, or southwest of the compass, or northwest of the compass. Whenever the correction is being done, the heading of the ship should be such that the spheres are at a direction which is a intercardinal direction from the compass location. So for doing the combined correction also, we need to take the spheres to a intercardinal direction. Now let's assume we are trying to take the starboard corrector sphere to the southeasterly direction of the compass. Now if you want to take the starboard corrector sphere southeast of the compass, that basically means that the sphere has to be turned clockwise. The sphere has to be turned or slewed clockwise by an angle of 35 degrees. It is right now at an direction of 100, and we need to take it to a direction of southeast, which is 135. So we have to turn it clockwise by an angle of 35 degrees. Now that means the vessel has to swing to the starboard side. Turning clockwise, looking from top means swinging to starboard. The vessel has to swing to the starboard side by an angle of 35 degrees. Now, if the ship swings to starboard by an angle of 35 degrees, the heading on which the ship would be that time is 035 degrees. So the heading of the ship will be 035 degrees. When the ship is heading 035, the starboard corrector sphere is going to come exactly southeast of the compass. The port side corrector will obviously automatically go to the northwest direction. The spheres are in reciprocally opposite direction. So if the starboard sphere comes southeast of the compass, the port corrector sphere comes northwest of the compass. So this is the heading on which the correction can be done. Up to here clear, beta?
So this alteration to by 35 degree in this case is for the maximum value or minimum value, sir, of deviation?
It is the maximum value of deviation which will occur here, beta. उसी heading पे हम correction करते हैं.
Copied, sir. ये minimum भी तो हो सकता है, sir, northwest and southeast.
Okay, beta, spheres के case में whenever the spheres are in a intercardinal direction from the compass, that is the time when the maximum deviation occurs. आप इसे डेल्टा और इको दोनों केसेस में चेक कर सकते हो.
इसे ये लास्ट वाला लाइन एक बार फिर बताएंगे.
The maximum deviation because of the delta and echo or combined delta echo will occur when the spheres are at a intercardinal direction from the compass location. कंपस के नॉर्थ ईस्ट में स्फीयर होगा, या कंपस के साउथ ईस्ट में होगा, या साउथ वेस्ट में होगा, या नॉर्थ वेस्ट में होगा, तो डेल्टा और इको की मैक्सिमम डेविएशन होगी.
Copied.
ओके, इसको आपको याद करना पड़ेगा. यू विल हैव टू मेमोराइज इट एंड देन यू हैव टू अप्लाई इट इन द गिवन सिचुएशन.
Copied.
Go ahead, beta. Another doubt?
So, sir, what we are trying to do here is we are turning the vessel by 35 degrees. And
that's correct.
All the cardinals will be shifted accordingly, but the degree, this difference of 10 degrees from their like opposite 100 and 280, the 10-degree difference which we have to correct will always be there. And we are turning the vessel just to correct them, correct?
No, मैं समझाता हूँ बेटा. आप जब शिप को 35 डिग्री टर्न करोगे तो नॉर्थ ईस्ट, साउथ ईस्ट, साउथ वेस्ट और नॉर्थ वेस्ट डायरेक्शन चेंज नहीं होने वाली. डायरेक्शंस वहीं पे रहेंगी जहां पे शो हो रही हैं. डायरेक्शंस डोंट चेंज. व्हाट इज गोइंग टू चेंज इज द ओरिएंटेशन ऑफ द स्फीयर. स्फीयर तो बिनैकल के साथ ब्रैकेट पे फिटेड है, उसे तो हम हिला नहीं सकते। सो स्फीयर को कंपस के साउथ ईस्ट में लाने का एक ही तरीका है कि वेसल की हेडिंग को 035 पे ले जाओ। जब शिप की हेडिंग 035 जाएगी तो हमारा स्टारबोर्ड स्फीयर 35 डिग्री आगे टर्न करेगा और कंपस के साउथ ईस्ट में आ जाएगा। एंड वी नो व्हेनेवर द स्फीयर इज एट ए साउथ ईस्टर्ली डायरेक्शन और ए इंटर कार्डिनल डायरेक्शन, डेल्टा इको की वजह से मैक्सिमम डेविएशन वहीं होती है।
At that time, we can correct them together.
Exactly, and that is where you do the correction. Go ahead, beta. Next out.
Sir, इसको
both the
sir,
questions.
what if अरे यार चल
I'll continue. Sir, in both the questions regarding one regarding IB and IC together and ENE together, sir, the heading of the ship was not given, sir, but we are assuming it to be north. So is that should I assume it to be north?
Assuming it north and then solving it is the simplest. आप अगर चाहो तो इसे किसी और हेडिंग पे भी कंसिडर कर सकते हो, आंसर उससे भी यही आएगा, but it will become a little complicated.
Right, sir. Sir, in this case, if we alter to port by 35 plus 45,
Very good, बेटा, very good, very good. अब बस यहीं पे रुक जाओ, मुझे थोड़ा सा और एक्सप्लेन करने दो। 3 ऑप्शन और हैं, मैं उनके बारे में अभी बता रहा हूँ, बाकी के डाउट्स उसके बाद लेंगे।
ठीक है सर, ओके
ओके। Now there is one more possibility which is available to us, and that possibility is, instead of taking the starboard corrector sphere to southeast direction, we can also take the starboard corrector sphere to the northeast direction. That is also a intercardinal direction. So the starboard corrector sphere can be taken to the northeast direction also. Now for doing that, the sphere has to be turned anti-clockwise by an angle of 55 degrees. Northeast direction represents 045. The sphere is at a direction of 100. So it has to be turned anti-clockwise by an angle of 55 degrees. This basically means that the ship needs to swing to port. Let me show you with an arrow. You can see this red color arrow showing that the ship needs to swing in the port direction by an angle of 55 degrees. And if the ship swings to the port side by 55 degrees, the heading of the ship will be 305 degrees. So if the vessel heads 305, the starboard corrector sphere will come northeast of the compass and the correction can be done. The port corrector obviously will come in the southwesterly direction then. So both the spheres will be lying in the northeast southwest direction of the compass. So we have obtained two options. One is heading 035, the second one is heading 305. Now if you look carefully, even if the ship goes on a heading which is reciprocal of 035, reciprocal of 035 would be 215. Even on that heading, the spheres will be lying at an intercardinal direction. You see, at 035 heading, the starboard sphere was southeast of the compass. When the ship goes to 215 heading, reciprocally opposite heading, this starboard sphere will go to northwest of the compass, reciprocally opposite direction. So the correction is also possible when the ship is heading 215, and the same applies to 305 heading also. If the ship goes on a heading reciprocal of 305, which comes out to be 125 degrees, even on this heading, the correction can be done. So these are the four headings which we have obtained: 035, 125, 215 and 305. All these headings are perpendicular to each other at a 90-degree difference from each other, and the correction for combined correction for coefficient D and E can be made on any one of these headings. So the answer is obtained as heading has to be 035, 125, 215 and 305. Any one of these headings the correction can be made.
सर वन क्वेश्चन
बोलो बेटा.
सर हमने इसको करेक्ट किया इंटर कार्डिनल पॉइंट पे बिकॉज डी मैक्सिमम है और ई 0 है इसी वजह से
नहीं बेटा, इस शिप में डी और ई दोनों हैं. इसमें डी और ई दोनों हैं, इसीलिए स्फीयर्स को स्लू किया गया है. अगर इसमें ई को 0 होता तो स्फीयर ऑथवर्ड शिफ्ट डायरेक्शन में होते. तो डेल्टा और ई को दोनों हैं, और जब हमें करेक्शन करनी होती है तो चाहे वो अकेला डेल्टा हो, चाहे वो अकेला इको हो, चाहे डेल्टा और इको का कॉम्बिनेशन हो, सभी केसेस में द प्रिंसिपल विच इज फॉलोड इज कि जहां कहीं भी स्फीयर लगे हुए हैं हमें उनको कंपस के इंटर कार्डिनल डायरेक्शन में लेके जाना होता है फॉर डूइंग द करेक्शन.
ओके
और
Sir,
डाउट बताओ बेटा.
sir, can you hear me, sir?
यस यस, गो अहेड बेटा.
Sir, in a similar way, IB and IC वाले problem में भी are there other alternatives? क्योंकि in that also we could have altered the other way.
ओके
Will that
बेटा, IB और IC में दे आर प्रोपोर्शनल टू साइन एंड कॉस ऑफ द कंपास कोर्स. वो सेमी सर्कुलर हैं, तो उसमें दो ही ऑप्शन आते हैं बेटा. वहां पे दो ही हेडिंग पे डेविएशन मैक्सिमम होती है और दो ही ऑप्शन आते हैं. यहाँ पे ये क्वाड्रेंटल डेविएशंस हैं, चार हेडिंग पे डेविएशन मैक्सिमम होती है, दैट्स वाई चार ऑप्शन यहाँ पे आते हैं. सो IB और IC में चार ऑप्शन नहीं आएंगे, वहां दो ही आएंगे.
okay, sir? Sir, अगर एक अभी के explanation के बाद time हो तो can we go to that slide and see so that it is clear, sir? तो मेरे को अभी भी थोड़ा doubt लग रहा है visualization में.
IB IC में बेटा.
Yes, sir. Yes, sir.
ओके, लेट अस फर्स्ट कंप्लीट डाउट सॉल्व करने के बाद मैं आपको IB IC की स्लाइड दिखाता हूँ.
Yes, sir. Sure, sir. Thank you.
ओके, और बताओ बेटा इसमें डाउट्स.
इस क्वेश्चन में ये तो कहीं दिया नहीं है सेम साइन और अपोजिट साइन, तो हम लोग किसी भी डायरेक्शन में स्लो कर सकते हैं.
ओके, अब सबसे पहले तो बेटा आप इसे इन चारों हेडिंग पे किसी भी हेडिंग पे शिप को लेके जा सकते हो और ये करेक्शन कर सकते हो. चारों ऑप्शन है हमारे पास. दूसरा, यहाँ पे डेल्टा इको का साइन तो नहीं दिया है, लेकिन हमें पता चल गया है कि दोनों का साइन सेम होगा. दोनों ईस्ट होंगे या दोनों वेस्ट होंगे. कैसे पता चला? क्योंकि स्फीयर को हमने क्लॉकवाइज घुमाया है. जो स्फीयर 090 पे होना चाहिए 10 डिग्री क्लॉकवाइज घुमा के 100 पे लाया गया है. दिस क्लॉकवाइज रोटेशन टेल्स अस दैट D and E are of the same sign. Getting clear बेटा?
सर ये 100 अंडरस्टैंड है सर, क्लॉकवाइज.
इन केस ऑफ डी ना, तो
हमारी
ईस्ट और वेस्ट में डी के केस में होना चाहिए ना सर.
Ask again बेटा.
ईस्ट वेस्ट डायरेक्शन में इन केस ऑफ डी कोएफिशिएंट है ना सर, इससे तो डी एंड ई टुगेदर है ना सर.
या दैट्स राइट बेटा. मैंने आपको बताया कि चाहे अकेला डेल्टा हो, चाहे इको हो, चाहे डेल्टा और इको का कॉम्बिनेशन हो, तीनों केसेस में जब भी आप करेक्शन करोगे तो स्फीयर्स कंपास से इंटर कार्डिनल डायरेक्शन पर ही होंगे. आप चाहो तो हम डेल्टा और इको में जाके इसे चेक कर लेते हैं दोबारा से.
ओके सर, थैंक यू सर. ओके,
और डाउट बताओ बेटा. ओके ग्रेट. अब मैं आपको पहले डेल्टा और इको में ये स्टेटमेंट चेक करवाता हूँ. सो लेट अस फर्स्ट गो टू इको. आई एम गोइंग टू इको नाउ. ये देखो बेटा, ये इको का डेविएशन डायग्राम आ गया. इको की डेविएशन मैक्सिमम कहाँ पे होती है? नॉर्थ, साउथ, ईस्ट या वेस्ट में होती है? आप ये चारों हेडिंग पे देख लो, जो स्फीयर्स हैं वो कंपस से इंटर कार्डिनल डायरेक्शन में हैं। या तो कंपस के नॉर्थ ईस्ट में है, या कंपस के साउथ ईस्ट में है, या कंपस के साउथ वेस्ट में है, या कंपस के नॉर्थ वेस्ट में है। करेक्ट बेटा?
यस सर।
यस
वेरी गुड, वेरी गुड। अब मैं आपको डेल्टा पे लेके जा रहा हूँ। ये है डेल्टा की डेविएशन। यहाँ पे मैक्सिमम डेविएशन हो रही है नॉर्थ ईस्ट पे, साउथ ईस्ट पे, साउथ वेस्ट पे और नॉर्थ वेस्ट पे। आप इन चारों हेडिंग पे चेक कर लो, जो स्फीयर्स हैं वो कंपस से इंटर कार्डिनल डायरेक्शन में है, या कंपस के साउथ ईस्ट में है, या कंपस के साउथ वेस्ट में है, या कंपस के नॉर्थ वेस्ट में है, या कंपस के नॉर्थ ईस्ट में है। करेक्ट?
यस सर। यस।
So this is the statement which we need to memorize, remember for doing these type of questions, कि चाहे डेल्टा हो, चाहे इको हो, चाहे उन दोनों का कॉम्बिनेशन हो, अगर हमें ये पता चल गया कि स्फीयर किस लोकेशन में फिटेड है, तो अब हमें बस एक ही काम करना है कि उनको कंपस से इंटर कार्डिनल डायरेक्शन में ले जाओ। जहाज को ऐसे स्विंग करो, स्टारबोर्ड या पोर्ट ऐसी हेडिंग पे ले जाओ कि स्फीयर इंटर कार्डिनल डायरेक्शन पे आ जाए। अगर कंपस से आप स्फीयर की बियरिंग लो, तो वो स्फीयर नॉर्थ ईस्ट, साउथ वेस्ट या नॉर्थ वेस्ट इन डायरेक्शन में होना चाहिए। क्लियर अप टू हियर बेटा?
सर लाइक इको नॉर्थ कार्डिनल पे थे और ये डेल्टा इज ऑन इंटर कार्डिनल,
यस,
रिजल्टेंट इनका हम
राइट।
लोग का इंटर कार्डिनल पे ही हम लोग
रिजल्टेंट बेटा इनके बीच में आएगा। डेल्टा की करेक्शन हमने की इंटर कार्डिनल हेडिंग पे, इको की करेक्शन हमने की कार्डिनल हेडिंग पे, तो डेल्टा इको का जो कॉम्बिनेशन होगा दैट विल बी सम हेडिंग बिटवीन इंटर कार्डिनल एंड कार्डिनल।
क्लियर सर, अंडरस्टूड, वो आंसर्स सारे अब समझ में आए
राइट।
मुझे।
इसीलिए देखो आप वो जो चार आंसर हमारे आए ना, 035, then 125, 215 and 305, they are somewhere in between cardinal and intercardinal.
यस सर, 035 प्लस 90 फिर 90 प्लस 90।
राइट, ग्रेट। अब मैं आपको आईबी और आईसी एंड इन दोनों की करेक्शन ये दिखा देता हूं, आईबी और आईसी की करेक्शन। सो लेट्स गो बैक टू आईबी आईसी करेक्शन। जस्ट गिव मी अ मिनट, मैं दोनों साइड बाय साइड खोल देता हूं बेटा। ये लो बेटा, ये मैंने ना दोनों को साइड बाय साइड खोल दिया है। लेफ्ट साइड में जो डेल्टा एंड इको की हमने करेक्शन की, और राइट साइड में जो हमने आईबी और आईसी का क्वेश्चन किया था, दोनों यहाँ पे हैं। सो हैव ए लुक। क्लियर हो रहा है बेटा?
हाँ सर। सर आईबीआईसी में नॉर्थ एंड साउथ पे if the Flinders sorry if the Flinders bar in the north and south की तरफ स्लूप किया मतलब by the means of altering our course,
नहीं
then
बेटा,
that
नहीं
not
नहीं, मैं अभी बता देता हूँ आपको। देखो, स्फीयर्स का तो हमने अभी फंडामेंटल देखा कि स्फीयर्स को हमें किसी भी इंटर कार्डिनल डायरेक्शन में लेके जाना होता है फॉर डेल्टा एंड इको। दिस फंडा इज क्लियर ना?
Yes sir, clear sir.
अब मैं आपको IB और IC का बता रहा हूँ कि IB और IC की हेडिंग कैसे निकालते हैं। सबसे पहले तो बेटा हमें फनल और वर्टिकल स्ट्रक्चर का रिजल्टेंट निकालना होगा। दिस रिजल्टेंट विल ऑलवेज बी ऑपोजिट टू द फ्लिंडर बार डायरेक्शन। अब ये
Yes
जो
sir.
रिजल्टेंट है, इस रिजल्टेंट को कंपस के ईस्ट या वेस्ट में लेके जाना है। ये दो ही ऑप्शन है हमारे पास। तो हमने 75 डिग्री स्टारबोर्ड में स्विंग किया तो रिजल्टेंट कंपस के वेस्ट में चला गया। हमने 105 डिग्री पोर्ट में स्विंग किया तो यही रिजल्टेंट कंपस के ईस्ट में चला गया। ये रिजल्टेंट कंपस के ईस्ट या वेस्ट में जाएगा, वहां पर ही मैक्सिमम डेविएशन होगी और वहां पर ही हम फ्लिंडर बार की करेक्शन करेंगे।
ओके सर। सर नॉर्थ और साउथ में क्यों मैक्सिमम नहीं होगा सर? कैन यू
ओके,
एक्सप्लेन दैट अगेन सर?
बिल्कुल बेटा। अगर आप इस रिजल्टेंट को नॉर्थ या साउथ में ले जाते हो, अब ये जो रिजल्टेंट है ये तो नॉर्थ या साउथ में कंपस को अट्रैक्ट या रिपेल करेगा। इट डज नॉट हैव एनी साइडवेज फोर्स देन। अगर कंपस के नॉर्थ या साउथ में कोई पोल आ जाए तो वो डेविएशन जनरेट नहीं कर सकता बेटा। सो दैट इज व्हाई दिस रिजल्टेंट, इफ इट गोज नॉर्थ और साउथ ऑफ द कंपस, it will not be able to generate any deviation at all.
ओके सर, ओके सर, थैंक यू सर, थैंक यू।
Okay, all right. और कोई डाउट
सर
बेटा? बोलो
सर एक डाउट था सर।
बोलो
डी
बेटा।
और कॉम्बिनेशन और ऑफ डी एंड ईस्ट तो समझ गया, बट एको इज द मैक्सिमम डिविएशन इज ऑन द कार्डिनल पॉइंट्स ना। तो सर हम लोग करेक्ट इसको इंटरकार्डिनल पॉइंट्स पे क्यों कर रहे हैं?
ओके, अब बेटा इसका रीजन में अगर जाओगे ना कि सर हम
हाँ।
स्पीयर्स को इंटरकार्डिनल पे क्यों लेके जा रहे हैं, तो
ओनली
ट्राई
इन
टू
केस ऑफ एको
अंडरस्टैंड
सर।
ओनली इन केस ऑफ इको। तो मैं आपको इको की डायग्राम दिखाता हूँ। ओके, लेट्स गो टू इकोज डायग्राम। ये रही बेटा इको की डायग्राम। ओके, अब आप अगर इस डायग्राम को ध्यान से देखो, हमें करेक्शन वहां करनी होती है जहां डेविएशन मैक्सिमम हो।
यस सर।
अगर आप इंटर कार्डिनल डायरेक्शन में जाते हो, यू टेक द हेडिंग ऑफ द शिप टू एनी इंटर कार्डिनल डायरेक्शन, तो वहां तो डेविएशन निल है, डेविएशन इज जीरो देयर।
यस सर।
मैक्सिमम डेविएशन हो रही है कार्डिनल हेडिंग पे। और जब आप
करेक्ट।
कार्डिनल हेडिंग पे जाओगे तो ये जो स्फीयर्स हैं, दे आर एट ए 45 डिग्री एंगल। दे विल लाई either northeast of the compass or southeast or southwest or northwest. This is from where this fundamental comes in.
Okay, okay sir. Okay, now it's clear.
Okay, all right.
So in that example, if we are keeping the values like 080 and 260, then it will be negative that you have mentioned that now we are turning in the positive side, the delta and echo.
अभी कर लेते हैं बेटा। देखो आपका स्फीयर 080 डायरेक्शन में है। ओके, आपको इसको लेके आना है 045 पे। करेक्ट। तो बेटा आपको 35 डिग्रीज पोर्ट में स्विंग करना पड़ेगा। समझ रहे हो बेटा? गेटिंग इट?
Yes sir, yes.
सो उस केस में 35 डिग्रीज पोर्ट में स्विंग करोगे, वो आपको एक हेडिंग देगा। उसमें 90 डिग्री ऐड या सब्ट्रैक्ट करते चले जाओ, चारों हेडिंग आ जाएंगी बेटा।
Then we'll get the 4 headings. Okay.
That's correct. Okay, so if it is clear, shall I close the presentation?
Yes.
Okay, all right. Okay बेटा, great. So आज आपने बहुत ही important concept जो हैं वो cover किए हैं. So these are the bouncer question which comes in magnetic compass, and if you have these concepts in mind now, you will be able to answer them. So इसके साथ ही बेटा हमने coefficients cover कर लिए हैं. अब जो टॉपिक्स हम कल कवर करेंगे, दीज विल बी नंबर 1 हीलिंग एरर, नंबर 2 द करेक्शन ऑफ द कंपस। उसमें मैं आपको बताऊंगा, अभी तो हमने इंडिविजुअल कोफिशिएंट्स देखे, अब हम combined correction करेंगे कि how when a compass adjuster comes he will start with which character and next one will be which one, next one will be which one and how we will complete it. So ये दूसरी चीज देखेंगे. And once we cover these two, फिर इनके साथ हम कुछ typical questions और typical questions हैं so which are based on the concept उनको देखेंगे. So that's the plan for tomorrow.
Okay, sir.